Let's look at example number 18 now. Here's our input file. The strings with the green check mark on the left are the strings that I want to select. The strings with the red cross mark on the left are the strings that I want to exclude. Let's look out for patterns which make the green ones differ from the red ones. If you observe all the green ones, you'll notice that they are all 3-digit numbers. The red entries are single-digit, 2-digit, 4-digit and 5-digit numbers, but none of them are 3-digit numbers. So we have a clear pattern here. So let's move to the next step. We have picked the 3 green ones alone and written them out in a separate list here. Now a digit can be any character from 0 to 9. So a digit can be represented by a character class with the ASCII range starting with 0 and ending with 9. So a 3-digit number can be represented by 3 such character classes written back to back. So here we have written all the 3 strings which are 3-digit numbers by using the character class repeated 3 times. We also have a line beginning and line end anchor tags at the left and right. Why do we need these? The reason is that we do not want matches done with a subset of the string. That is, we do not want to match against substrings. To explain this further, take a red marked number from the input list, say the 4th red one, 45687. This is a 5-digit number. Take a substring of this, take the middle 3 characters, 568. It forms a 3-digit number. Just because it contains a 3-digit number somewhere in between, we don't want to identify it as a positive match. We are only interested in matching the whole string. In order to ensure this, we put the anchor at both ends. This way, the match will be run only against the whole string and not substrings. Please note that we are doing it this way because the situation calls for it. In other situations, we might want to search for a pattern anywhere in the string. In that case, anchor should not be provided. Now, what if we want to represent 10-digit numbers? It might be cumbersome to write the character class 10 times over. We need a better compact way to represent this. This leads us to our next regex symbol, the repeater. It is represented by opening and closing curly braces with a number in between. This number signifies the number of repetitions. So A followed by the number m in curly braces means exactly m repetitions of the letter A. Remember the asterisk that we have been using so far? The limitation with asterisk is that you can't represent an exact number of repetitions with it. If you say A star, it could mean 0 up to any number of recurrences. The curly braces repeater allows you to specify exactly m repetitions. Let's move to our final step. We have to come up with a single regex pattern that can represent all the 3-digit numbers. So first, we will write the start anchor, then the character class for a single digit, which is 0-9 inside square brackets, then the number 3 within a set of curly braces, then the ending anchor. So how it reads is caret, then a digit character class repeated 3 times, then a $. So our final regex pattern for example number 18 is ready. Let's try it out using a regex engine. Let's bring up our Linux terminal. First, let's see our input file. So cat input file name. There it is. Now grep hyphen uppercase E, the regex pattern in single quotes, and then the input file name. There you go. Compare this list with what you saw in the graphic for this example. Only the green ones should have got matched. Let's move on to the next one. Let's look at example number 19 now. Here's our input file. The strings with the green check mark on the left are the strings that I want to select. The strings with the red cross mark on the left are the strings that I want to exclude. Let's look out for patterns which make the green ones differ from the red ones. The first green entry is a 4-letter word. Second one, tiger, is a 5-letter word. Third one, mouse, is also a 5-letter word. The next one, cuckoo, is a 6-letter word. And the last green one, deer, is a 4-letter word. The red entries are 3 letters, 7 letters, and 8-letter words. So we don't have a clear pattern here. So let's move to the next step. We have picked the 5 green ones alone and written them out in a separate list here. We have a line beginning and line end anchor symbols at the left and right. For the same reason we had in the previous example, we do not want to match substrings. We use the character class A-Z inside square brackets to represent any English letter. Then we use the curly bracket repeater symbol with a number inside. This number signifies the number of letters used in that word. So if you look at the numbers alone, the lowest one is 4 and the highest one is 6. So our range of green words are at least 4-letter words and at most 6-letter words. So can we create a range of repetitions rather than an exact repetition? This leads us to a slightly different flavor of the curly braces repeater. Here it is. So notice that this one has 2 numbers inside the curly braces separated by a comma. So M and N denote the range of repetitions. So if we say A and in curly braces M, N, it represents at least M repetitions of the letter A and at most N repetitions of the letter A. Let's move to our final step. We have to come up with a single regex pattern that can represent all the green words. So we again use the character class A-Z and follow it with a repeater range from 4 to 6 and enclose it within anchors. So this means any word made up of English alphabets which is at least made up of 4 letters and at most made up of 6 letters. So this pattern selects 4-letter, 5-letter and 6-letter words only. And it will exclude all others like 3-letter, 7-letter, 8-letter words. So our final regex pattern for example number 19 is ready. Let's try it out using our regex engine. Let's bring up our Linux terminal. First, let's see our input file. So cat input file name. There it is. Now grep hyphen uppercase E, the regex pattern in single quotes, and then the input file name. There you go. Compare this list with what you saw in the graphic for this example. Only the green ones should have got matched. So that's it for this session. Let's move on to the next one.